Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 4th, 2025, about 3 days ago. The main punchline is that this paper delivers a tabular and context learning model that matches or beats state-of-the-art methods while scaling to wide tables, with a zero-shot mean rank of 3.58 across benchmarks. The paper is titled Orion-MSP, Multi-Scale Sparse Attention for Tabular and Context Learning. And as we'll see later, the mix of multi-scale processing, sparse attention, and a perceiver-style memory has significant implications for efficient model training. On Hugging Face, find Orion-MSP checkpoints for tabular and context learning, a model card, quick start examples using fit and predict, and benchmark results. No explicit parameter sizes listed. Figure 1 summarizes the full pipeline, showing how raw tables become predictions in a single forward pass. The model first embeds each column into dense vectors, which means every feature gets a learned representation tailored to its distribution. Multi-scale sparse row interaction then groups features at 1, 4, and 16, using CLS and global tokens, where CLS marks a summary slot and global spreads long-range links. A perceiver-style latent memory enables safe communication because only training rows write while all rows read. The in-context predictor finally maps the enriched representations to labels without gradient updates. While Figure 2 shows how the model keeps attention efficient by connecting only a few strategically chosen pairs instead of everything. The sliding window focuses each feature on its neighbors with a window size of 8. Special tokens act as global hubs, and there are 4 of them to spread information across the table. Random links add a couple of long jumps, with 2 per position, which preserves reachability while cutting computation from quadratic to near linear. Alright, Table 1 summarizes head-to-head accuracy and F1 across 3 suites and reports a mean rank, which is an average placement where lower is better. The table shows Orion-MSP leading with an overall rank of 3.58. On talent, accuracy is 0.846 and F1 is 0.836. On OpenML, accuracy is 0.872 and F1 is 0.868. On Tabzilla, accuracy is 0.882 and F1 is 0.879. So Table 2 examines how performance shifts with dataset size, showing that the method stays competitive from small to large sets. The strongest large set scores come from XGBoost, which leads because abundant examples favor tree ensembles. The method leads or ties most often on small and medium sets, which suggests the multi-scale sparse attention generalizes well when data are limited. TabPFN peaks on medium sets, while Context Tab and Mitralag. These trends support the scalability claim without task-specific fine-tuning. Alright, Table 3 breaks results by feature dimensionality, meaning how many features each dataset includes. The table shows Orion-MSP leading on narrow datasets, with accuracy about 0.84. Performance remains strong on medium and wide cases, because sparse multi-scale attention scales with width. Tree ensembles post the highest wide accuracy, with CatBoost near 0.916, while TabPFN delivers the best wide F1. Overall, the method avoids the usual drop on wide tables, which signals effective long-range feature interactions. Okay, 2 takeaways stand out. Multi-scale sparse attention with a perceiver-style memory delivers state-of-the-art zero-shot results while keeping attention costs near linear, and the model stays strong on wide tables and limited data. The broader implication is practical, scalable in context learning for real enterprise tabular workloads. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.